Hi guys, back into this mode again. So it's about 6:30 in the morning. I think the majority of these we got through with cohort B, but I know cohort A, we didn't get through them all. I know we did this guy and this guy, and then we were starting to work on this guy right here. And then we got called down for that sort of get together in the cafeteria. So we'll just do all the rest of them. Okay. So let's see. We'll start with that second one down. Okay, and I'm going to have to use the product rule and the chain rule here. Okay. So when I do the derivative here, I've got this times that. Okay. So I've got to go the first x plus 5 squared times the derivative of the second. So the derivative of x minus 1 squared plus the second x minus 1 squared times the derivative of the first x plus 5 squared. Okay, so this right here is where you have to use the chain rule, right there and right there. Okay, so I just bring that first binomial down, x plus 5 squared. Okay, now right here, if I let u be my x minus 1, okay, then I take the derivative and I get 2u to the first. So it'd be 2 times x minus 1 to the first times the derivative of u, which is just 1. Plus, bring this guy down, x minus 1 squared times, okay. So right here, I have to use the chain rule. So if I let u be x plus 5, okay, then that's the derivative of u squared. So I just get 2u to the first. So 2u, which is x plus 5, to the first, times the derivative of u, and the derivative of x plus 5 is just 1. Okay, so from here on out, I just got to clean things up. Okay, so let's see. Well, I could write this first guy, okay, as 2 times x minus 1 times x plus 5 squared plus this guy right here, I could write it as 2 times x minus 1 squared times x plus 5. Okay, now that's one form of the answer, but I don't think that's the simplest form. Because what I want to start looking for is, do we have a GCF I could pull out? Okay, and so if we look, I've got a common factor of 2, which I can pull out. Notice I have a common factor of x minus 1, so I can pull one factor away from here and one factor away from here, so that'd be x minus 1. And then notice that I have a common factor of x plus 5. Okay, so I can pull one away from here and one away from here, okay, and pull that guy outside. Okay, so I get this x plus 5 outside, and I say, okay, what am I left with inside? Well, from here, I pulled away the 2, the x minus 1, and one factor of x plus 5, so I'm left with a factor of x plus 5. Over here, I've pulled away the 2, I've pulled away the x plus 5, and I've pulled away one factor of x minus 1, so I'm left with another factor of x minus 1. Okay, so all we have to do is just simplify in here by collecting similar terms. Okay, so I have 2 times x minus 1 times x plus 5. Okay, and then when I add these, notice I'm going to get 2x plus 4. Okay, and so I asked myself, okay, can I do anything else? Well, notice you have a GCF here. Okay, and notice that guy is 2 times the quantity of x plus 2. So notice I can take this, bring them out front, okay, as another GCF. So I would have 2 times 2 out front. So I'd get 4 times x minus 1 times x plus 5 times, sorry, that'd be x plus 2. Okay, and so that is clearly one form of the answer. Okay, now obviously if you wanted to keep going and you wanted to multiply these three guys together, okay, and form a big polynomial and then distribute the 4, you could go ahead, but I would just leave it in factored form like that. Okay, so let's see, that takes care of this guy. Okay, so now we come down to this fourth one. And right now, we could just go, okay, let's use the product rule, and let's go the first times derivative of the second plus the second times derivative of the first. You could do that, and it would work. But I'm also looking at both of these trinomials, and they're both perfect squares, okay? So I could rewrite this just like this guy, okay, and then apply the same thing. So let's see what happens. Okay, f of x, well, let's see, this is x plus 2 squared. And this is x minus 3 squared. Okay, so notice that this guy and the one we just got done are real similar. Okay, so if I take the derivative, I could use the product rule and the chain rule. So I take the first, x plus 2 squared times the derivative of the second, okay, x minus 3 squared, plus the second, x minus 3 squared times the derivative of the first, x plus 2 squared. Okay, and then right here, I have to use the chain rule, and right here I have to use the chain rule. Okay, and so when I'm using the chain rule here, my u is x minus 3. Okay, and here the chain rule, my u would be x plus 2. Okay, so let's see what we got going on. I bring this x plus 2 squared down. Okay, so if this is the derivative of u squared, then I would get 2u to the first times the derivative of u, which would be derivative of u is just 1. Okay, and I probably shouldn't have put the u in there. I'll come back and fix it. I'll do the same thing over here. Bring the x minus 3 down. So I get x minus 3 squared times, okay, if this is u squared, then the derivative of u would be 2u to the first, so I'll 2u to the first times the derivative of u, and the derivative of x plus 2, which is u, is just 1. Okay, so I probably shouldn't have written the u there and the u there because these are still x's, but I did. Okay, so we will resubstitute back in there. Okay, so I'm going to get x plus 2 squared times 2 times my u here is x minus 3 plus, bring this guy down, x minus 3 squared times 2, and my u here is x plus 2. Okay. All right, so again, we start looking for a GCF just like the last one, and notice that I have a common factor of 2 I can pull out, so I pull that guy out. And notice I have a common factor of x plus 2 I can pull out. Okay, so I pull out an x plus 2. Okay, and then I also have a common factor of x minus 3 that I pull out. So that's my x minus 3. So that's my GCF. And so I say, okay, what am I left with? Well, here the 2 goes away, the x minus 3 goes away, and one factor of x plus 2 goes away. So I'm still left with one of them, x plus 2. Plus, okay, here again, the 2 goes away, the x plus 2 goes away, and one factor of x minus 3 goes away. So I still have one more factor of x minus 3. Okay, and then we just simplify that by collecting similar terms. So 2 times x plus 2 times x minus 3. And then let's see, this would be 2x minus 1. Okay, and then just like the last one, I looked, do I have another GCF here I could pull out? And the answer to that obviously is no. So again, that's one form of the final answer. If you want to keep going and you want to multiply all three of those guys together and expand it, you can. I would just leave it the way it is because I think it's a clean looking answer. Okay, so we're good there. Okay, so now we got that guy done. Now we got to do this guy. Okay, so let's see. Can I mess around with this guy? Well, the first thing I'm thinking is, can I just go ahead and apply the chain rule right now? Absolutely, okay? You could use -2 as your exponent. You could let your u be this trinomial in there. But you know, something I'm wondering about, notice that this guy was a perfect square trinomial, so was that guy. I wonder if this guy is. I wonder if this guy factors as a perfect square. So let's take a look and let's see what happens. Okay, so if it does, well, the square root of 4x squared is 2x, and the square root of 9 is 3, okay, and this is plus, so it would be like this if this works out, but it's all to the -2nd power. So I say, okay, if I take this and expand it, well, we know when we square 2x, we get 4x squared. When we square 3, we get to 9. Okay, the plus goes to the plus. So is the middle term the right one? Well, it would have to be 2 times 2x times 3. Well, 2 times 2x is 4x times 3, okay, is 12x. Yeah, so that was a perfect square. Okay, so if I put it in factored form and then use my power of a power rule here, multiplying exponents, this will be the same as 2x plus 3 to the -4th power. And then I look at this guy and look at this guy and say, okay, which one's easier to take the derivative of? Probably this one. Now, is this one still easy to take a derivative of? Absolutely. Okay, but this might be a little bit easier. Okay, so we have this f of x equals 2x plus 3 to the -4th power. And so if I let u be my 2x plus 3, okay, then my du dx is just 2. Okay, so let's take our derivative, f prime of, well, let's do the u substitution first. So let's go f of u equals, this would be u to the -4th. Okay, so my f prime of u would be -4 u to the -5th times du dx. Okay, and then I go back to substituting in, so my f prime of u becomes f prime of x. So I get -4 times u, which is 2x plus 3, to the -5th power times du dx, which is just 2. And of course, we don't like negative exponents. Okay, so we're going to get rid of those negative exponents and clean things up. Okay, so it looks like this. 2x plus 3 to the -5th will become 2x plus 3 to the 5th power down in the denominator, and then up above I'd have -4 times 2, which is -8. And there we go. We got our answer. Okay, and it's a clean looking answer. So we should be in good shape there. Okay, so that takes care of all of these guys here. Okay, so now I got to start working on the trig. Okay, so you might want to grab your sheet that I gave you, okay, with all of the trigonometric derivatives, because that might come in handy. Okay, I'm trying to think of, do I have one of these in here? Okay, there we go. Okay, so you might want to grab this guy and keep it handy just in case. Okay, you might need it, you might not. All right, so we'll see what's going on here. Okay, so let's see this first guy. Okay, so we've got f of x equals the sine of 4x. So if we're going to use the chain rule, once again, let the u be whatever's inside. So this would be your u in here. Okay, so my u is 4x, which means the derivative, du dx, is just 4. Okay, so let's do our u substitution. So f of x becomes f of u. So this is just the sine of u. Okay, so I take my derivative, f prime of u, and the derivative of the sine is the cosine right here. Okay, so I get cosine of u times du dx. Okay, and then I just go back and substitute my x in, so f prime of u becomes f prime of x, and that's what we're looking for. So I get the cosine of u, which is 4x, times the derivative of u, which is 4. Okay, and so we just rewrite it as 4 cosine of 4x, and you have your derivative. Okay, so we're good there. Okay, so this guy's down. So now we just got to do this guy. Okay, let's see what we got going on there. Okay, f of x is sine of 2x minus 7. So if I let u be what's inside the 2x minus 7, then my du dx is just 2. Okay, so we're good. So do our u substitution. So this becomes f of u equals the sine of u. Okay, so f prime of u is, once again, the derivative of sine is cosine, so I get cosine of u times the derivative of u, du dx. And then we go back and substitute in, so f prime of u becomes f prime of x. And so we get cosine of u becomes a cosine of 2x minus 7 times du dx is just 2. And then we just rewrite. Okay, so 2 times the cosine of 2x minus 7. Okay, so those first two trig functions pretty easy to work with. Okay, so we got those guys out of the way, so we just got to do these last couple. Okay. All right, so we have f of x equals cosine of 6x. Once again, let u be what's inside, so let the u be the 6x. So your derivative of u, du dx, is just 6. Okay, so do your u substitution. So f of u becomes cosine of u, and then we take our derivative with respect to u. So f prime of u is the opposite of the sine of u times du dx. Okay, so derivative of cosine, once again here, derivative of cosine is the opposite of sine. Okay, and so then we go back and just substitute. Okay, go back to our x's, so f prime of u becomes f prime of x. And so we get the opposite of the sine of u, which is 6x, times the derivative of u, which is 6. And then just rewrite. So we get negative 6 sine of 6x. Okay, and we are done. Okay, so we got one more to do. This last guy right here. Okay, let's see. Okay, so f of x equals cosine of x squared minus 1. So again, u is what's inside, the x squared minus 1. Okay, so the derivative of u, du dx, just ends up being 2x minus 0, so 2x. Okay, so do our u substitution. So f of x becomes f of u. Cosine of x squared minus 1 becomes cosine of u. And then we take our derivative with respect to u. Okay, so I get the opposite of the sine of u times du dx. And then we go ahead and substitute. So f prime of u becomes f prime of x, and that's exactly what we're looking for. And so we get the opposite of the sine of u, which is x squared minus 1, times du dx, which is 2x. And then we just rewrite. So I get negative 2x sine of x squared minus 1. And we are done. And that takes us down our first list here. Okay, and notice once you get the hang of using the chain rule, okay, how easy this stuff is. More to come.